So this is starting. I'm going to be doing a unit 4 test corrections, and the units I'm going to be doing are energy and oil, energy efficiency, and nuclear energy. So starting off with energy and oil, we're going to talk about the historical energy use. Before 1900s, 1850s, we've used wood, and then after that, we've had coal, and then now we use oil and gas. And then there are two laws that kind of just show the type of energy use. So the first law of thermodynamics is when it takes high quality energy to get high quality energy back. That's kind of just an easy step. You take it, and it's like a lot of energy. Second law of thermodynamics is where you get some high quality energy is wasted at every single step, so it takes more energy to produce or to extract these energy sources. And then we have petrochemical, which are products of oil distillation. Examples would be paints, pesticide, rubber, Vaseline, and a bunch of others. And then we go into the oil consumers. So largest consumers in 2009 were U.S., China, and Japan. And then that's just going off of how much we need, population, and it's obviously increased since then. And then we have proven and unproven oil reserves. So proven would be identified deposits that can be extracted, and then unproven would be like the ones that have less chance of recovery. And then we have peak production. So Hubbard's prediction, which is a prediction that was made that the U.S. oil production would peak. So an example would be this. So correct, incorrect, it was correct. In the 1970s, our oil production did peak, and then after that, it kind of just went down. And then we have OPEC, so that's Organization of Petroleum Exporting Countries. And these are countries that control most of the world's oil. Examples would be Saudi Arabia, Venezuela, Libya, and a bunch of others. So that's quickly just going over the oil, what's it called? Part of the energy PowerPoint. And then we have energy efficiency. So that would be using or saving oil. So, not oil, energy. And then we have the fact that it can save the U.S. up to 43% of the energy that we have, which is a bunch. That would be so helpful. The 4 widely used devices would be the light bulb, the combustion engine, the power plant, and there's nuclear power plant, and there's a coal burning power plant. And then mass transit would be like the one that uses the least amount of energy compared to those 4. And then we have advantages. One advantage would be the prolonging of fossil fuels. So you could save up fossil fuels for a needed time, low cost, reduces pollution, and a high net energy yield. Cogeneration is where you use 2 forms of energy from the same fuel source. So it's kind of just one fuel source, 2 energy. So boom, yeah. So yeah, that's a quick demonstration. And then we have fuel efficiency. So this is the CAFE standard. So this would be the corporate average fuel standards. And this is kind of just regulating how much energy, or how fuel efficient we can be. And it has not increased after 1985. That's a quick summary, and then now we're going to go into nuclear energy. So we use fusion, and that is when you split an atomic like in half. Yeah, you split an atom in half, and it just releases a lot of energy. So then we use that, and then there's fission, which only occurs in stars. There's fusion that only occurs in stars because we use nuclear fission, and it only occurs in stars because it takes very, very high temperatures to attain that. So then now we have the nuclear fuel cycle, which is where you mine uranium-235, which is what we use to get nuclear energy, process it to make fuel, and use it in a reactor, and then you safely store the radioactive waste, and then you decommission the reactor. So there are 2 ways of There are 2 ways of properly handling the nuclear energy power plant. So they last up to 40 years. You can either once you're done, you can either entomb it or dismantle it. So entombing would just be packing it up, compacting it as as hard as you can, I guess, and then just putting it in the ground. And then we have dismantling, which is where you dismantle it, take it piece by piece. So what is happening to nuclear power? So it is the slowest growing energy source, just because of the fact that there are safety concerns. I mean, it is very radioactive if anything happens. Low net energy yield, and it needs greater subsidies. And there's also concerns of transporting uranium. So yeah, that's just a quick overview of the nuclear energy power plant. So that is it for my Unit 4 test corrections. I hope you have a good spring break, Ms. Clay.